You are made of dead stars. Literally. The calcium in your bones came from exploding white dwarfs. The iron in your blood was forged in the core of a supergiant that died before the sun was born. The gold in your jewelry, if you have any, required two neutron stars colliding to exist. Every atom in your body, except hydrogen, was manufactured inside a star that no longer exists. You are not just in the universe. You are the universe, in human form, looking back at itself. After the Big Bang, the universe contained almost nothing useful for life. Just hydrogen, some helium, and traces of lithium. No oxygen, no carbon, no metals. If you tried to build a human from the early universe, you couldn't. The ingredients didn't exist. For hundreds of millions of years, the cosmos was a dark, boring place. Hot gas, cooling in an expanding void. Life was impossible. Then stars ignited. In their cores, hydrogen atoms smashed together at temperatures of millions of degrees, fusing into heavier elements. Stars became cosmic forges, manufacturing the periodic table one nuclear reaction at a time. But here's the thing. Stars hoard their creations. The heavy elements stay locked inside until the star dies. Only stellar death releases them. Exploding supernovae scatter newly forged atoms across space. Dying giants shed outer layers thick with cosmic ingredients. The elements inside you aren't just from stars. They're from dying stars. Your body is made of stellar corpses. Stellar nucleosynthesis, your atomic factory. Inside every star's core, the conditions are extreme. Temperatures of 15 million degrees, pressures where atoms are crushed together against their will. Hydrogen nuclei, single protons, smash together and fuse into helium, releasing enormous energy. This is what makes stars shine. It's also what made the helium atoms that, billions of years later, would fill birthday balloons on Earth. But fusion doesn't stop at helium. In larger stars, the helium itself fuses into carbon, the backbone of every organic molecule in your body. Carbon fuses into oxygen, the element you're breathing right now. Oxygen fuses into silicon, neon, magnesium. Silicon fuses into sulfur, argon, calcium. Each step requires higher temperatures, more pressure, more violence. The stellar furnace works its way up the periodic table, creating heavier and heavier elements. But there's a limit: the iron ceiling. Iron is where fusion stops being profitable. Fusing elements lighter than iron releases energy. Fusing iron, or anything heavier, consumes energy. It's like trying to squeeze water from a stone. You put more in than you get out. When a massive star's core fills with iron, it's reached a dead end. Fusion can't continue. The core's energy source switches off. And then, in less than a second, disaster. The star collapses. The outer layers slam inward at 70,000 kilometers per second. The core compresses into a neutron star, or black hole, and the infalling matter rebounds off this ultra-dense core in a catastrophic explosion, a supernova. For a few weeks, a single dying star outshines entire galaxies. In that blast, the heat is so extreme that fusion goes beyond iron anyway, creating gold, platinum, uranium, everything up to the heaviest atoms. Then it scatters. The elements forged over millions of years, and the elements forged in seconds during the explosion, spray across space at thousands of kilometers per second. The cloud that made you. About 4.6 billion years ago, a cloud of gas and dust, already enriched by countless stellar deaths, began to collapse. Maybe a nearby supernova triggered it. Maybe it was random gravitational fluctuation. Either way, most of the cloud became our sun. But a small fraction formed a disk of debris that would become planets. Every atom of calcium, iron, oxygen, and carbon that would eventually form you was in that cloud. Already dead, already scattered by explosions, already waiting. The recipe for a human. Let's trace your specific atoms. Oxygen, 65% of your body mass, created in the cores of massive stars, specifically during the carbon-burning phase when temperatures exceed 500 million degrees. The oxygen in your lungs was forged deep inside a star at least 8 times more massive than the Sun, which then exploded and ceased to exist billions of years ago. Carbon, 18% of your body mass. The triple alpha process, 3 helium nuclei fusing in a precise sequence, creates carbon. This process is so finicky that if the nuclear constants were even slightly different, carbon wouldn't exist, and neither would you. Hydrogen, 10% of your body mass. This is the exception. Your hydrogen is primordial, created in the first minutes after the Big Bang itself. The hydrogen in your water molecules is almost 13.8 billion years old. Nitrogen, 3% of your body mass. Forged in less massive stars through the CNO cycle, a circular sequence of nuclear reactions. The nitrogen in your DNA predates the solar system. Calcium, 1.5% of your body mass. This one's specific. Calcium comes primarily from type 1a supernovae, white dwarf stars that explode when they accumulate too much mass from a companion. The calcium building your skeleton right now came from a stellar explosion completely unlike the one that made your oxygen. Iron, 0.006% of your body mass, but crucially important. Iron makes your blood red. It's the core of hemoglobin, the molecule carrying oxygen to your cells. This iron was forged in the last moments of a massive star's life, the final fusion product before collapse. Your body is an archaeological site. Different atoms came from different stellar deaths, different cosmic events, different epochs of the universe. The neutron star collision in your jewelry. Elements heavier than iron require something even more extreme. Neutron star mergers. When 2 neutron stars spiral together and collide, they create conditions so violent that atomic nuclei are smashed together in rapid succession. The R process, rapid neutron capture. Gold, platinum, and many other heavy elements form primarily in these mergers. A single neutron star collision produces several Earth masses worth of gold. So if you're wearing a gold ring, that gold came from 2 neutron stars that were once 2 separate massive stars that both exploded as supernovae, that happened to leave behind neutron stars that happened to orbit each other and in spiral for billions of years until they finally merged in an explosion visible across the universe. That's the history of your jewelry. The death that made you possible. Here's the uncomfortable truth. Your existence required destruction on a cosmic scale. For the atoms in your body to exist, stars had to die. Lots of them. Each element in you traces back to nuclear cataclysm. Fusion furnaces that burned for millions of years, then exploded or collapsed. The supernova that scattered your oxygen might have had planets. If it had life, microscopic or intelligent, that life was vaporized. Everything near the dying star was destroyed so that billions of years later, you could breathe. You are collateral benefit. a side effect of stellar death, built from the scattered remains of cosmic violence. The recycled universe. And it doesn't stop with you. When you die, your atoms will disperse. Some will enter the soil, become plants, become animals, become other humans. Some will enter the atmosphere, drift into space, perhaps someday be incorporated into new stars. In 5 billion years, our sun will expand into a red giant, engulf the inner planets, and eventually shed its outer layers as a planetary nebula. Whatever remains of Earth, whatever remains of humanity's atoms, will scatter into the interstellar medium. And billions of years after that, some of those atoms might enter a new stellar nebula, form a new planet, become part of new life. The iron in your blood might eventually be in someone else's blood, or something else's blood, or a structure we can't imagine. You are not the end point. You're a temporary configuration of atoms on their way somewhere else. The scale problem. You contain about 7 octillion atoms, 7 times 10 to the 27th. Each one has been through at least one star. Many have been through multiple. They've existed for billions of years before you and will exist for billions of years after. Your consciousness is a brief gathering, a momentary meeting of ancient particles that, for a few decades, cohere into a person. Then they scatter again. But this makes you remarkable. The universe is mostly dark matter, empty space, and diffuse gas. The chance of atoms coming together to form anything interesting is small. The chance of them forming a living thing is smaller. The chance of them forming a conscious being who can understand their own origin? Infinitesimal. You are atoms arranged in a pattern so complex that you can contemplate your own atomic origin. You are the universe examining itself. Every star that died to make your elements did so without purpose. Stellar evolution has no goal, but the result, you, here, reading this, is something no individual star could achieve. You are more organized, more intricate, more aware than any star that contributed to you. Your consciousness represents a complexity those stellar furnaces never approached. And you carry a gift they gave without knowing. The cosmic connection. When you look at a star, you're seeing a distant cousin. The atoms in that star are the same types as the atoms in you. Some might have come from the same stellar ancestor, scattered in different directions. The connection isn't mystical, it's physical. You are related to the cosmos in the most literal way possible, made from it, part of it, eventually returning to it. The iron in your blood and the iron in Mars's rust came from the same stellar forge. The oxygen you breathe and the oxygen frozen in distant comets share the same nuclear origin. You are not a visitor to the universe. You are the universe, temporarily gathered into a human shape. Every atom in you is ancient, borrowed, eventually returned. This isn't science fiction. It's the most verified scientific fact. You are made of dead stars. Literally. Thank you for watching. Don't forget to like, subscribe, and enable post notifications.